Okay, let's unpack something really interesting here. It's from the world of AI and sports predictions.
Yeah. What do we got?
SmartBet AI. They've looked at the upcoming CF Montreal versus Philadelphia Union game. That's May 3rd, 2025.
Okay.
And the numbers they've crunched are, well, surprisingly specific. Like, they point out this tiny ELO rating difference. Montreal's at 1473.06, Philly's slightly higher at 1499.37.
That a huge gap then.
No, but then the AI gives Montreal a 44.86% chance of winning at home. That feels pretty granular,
Yeah,
right?
that's getting down to the decimal points. Where's this coming from?
It's part of the Gambler's Ruin project in their SmartBet AI. They usually focus on the Premier League, apparently. But this report zeroes in on this specific MLS match.
Ah, okay. It's fascinating how much analysis goes into these things now before a ball's even kicked.
Totally. It's way beyond just looking at the last few results. These AI systems, they're all about probabilities, aren't they? Trying to map out all the different ways a game could potentially unfold.
Exactly. It's about dissecting the possibilities.
And that's really what this deep dive is all about for us today. We've got the full analysis, the report right here.
So the goal is to understand the why behind the numbers.
Precisely. Think of it like getting a peek under the hood of modern sports analytics. We want to explore all the factors they're considering: injuries, stats, different models.
Which should give you, the listener, a real sense of the complexity involved. It's not just one magic formula doing all the work.
Right. It's a whole mix of different approaches, each kind of looking at the game from its own angle.
Different perspectives, giving different insights, potentially.
Absolutely. And this report lays it all out. We've got the match details, the teams, the date, again, May 3rd, 2025. Venue, Saputo Stadium in Montreal.
Kickoff time, weather.
Yep, 7:3 Euro PM Eastern. And the weather looks like a cloudy evening, around 49 Fahrenheit, feels like 47. Bit of wind, W&W at 6 mile per hour, but only a tiny 3% chance of rain.
Okay, so probably not a huge weather impact, but still, it's a data point they include. Even subtle things can matter sometimes.
Good point. And speaking of things that definitely matter, injuries, they can really shake things up.
For sure. Who's out?
For this one, CF Montreal is listed without Bryce Duke and Giacomo Vrioni, both lower body injuries, marked as OUT.
Okay, two key players, potentially.
And Philadelphia Union, they're missing Ian Glavinovich with a knee injury, also OUT.
That's definitely significant. And the big question is always how these absences get, factored into the models. It directly changes the team's potential on the pitch.
Well, this SmartBet AI, it uses a kind of hybrid approach, it seems.
Hope so.
It uses something called Poisson regression, mainly for guessing the number of goals each team might score.
Ah, okay. Common in soccer analytics for goal count.
Right. But then for the actual outcome, win, draw, lose, it brings in machine learning classifiers, things like random forest, XG boost, and even a neural network.
Interesting blend. So Poisson for the how many and machine learning for the who wins.
Seems like it. Poisson regression is all about that probability math for count data, like goals.
Yeah, calculating likelihoods based on average rates.
And the machine learning stuff, that's more about pattern recognition, right? Finding complex patterns in huge amounts of data to predict the result.
Exactly. And these models, they aren't just using basic win-loss records, I assume.
No, definitely not. The report mentions they integrate a whole load of features. Things like bootstrapped Poisson models for expected goals.
Okay, so refining the goal prediction.
Dynamic ELO ratings that change over time, loads of contextual team features, recent form, XG, home away advantage, those injuries we just talked about, goal efficiency.
Goal efficiency, so how good they are at converting chances.
Yeah, exactly. And even market odds, what the betting markets are saying.
Right, harnessing the wisdom of the crowd in a way, or at least the money flow.
And it's all fed into these advanced classification models, trained with techniques like SEMOT for handling imbalanced data and hyperparameter optimization to fine-tune them.
So they're really throwing a lot of sophisticated techniques at this. It shows how much data processing is happening behind the scenes. It's not just surface-level stats.
And they even mentioned the less glamorous stuff, like data cleaning, using fuzzy matching and Unicode normalization to make sure team names line up properly.
Oh, that's crucial. Garbage in, garbage out, right. The predictions are only ever as good as the data foundation. Messy data can completely derail the analysis.
Makes sense. Okay, should we dive into some of these specific tools they're using, starting with that ELO rating?
Yeah, let's do it. ELO's pretty well known, comes from chess originally, right?
That's the one. It's basically a dynamic power ranking. Teams gain or lose points based on who they play, the result, and how strong the opponent was.
And the report gives this specific ratings.
Yep. CF Montreal at 1473.06, and Philadelphia Union slightly higher, 1499.37.
So Philly has the edge based on historical performance tracked by ELO. But like you said, it's not a massive difference. Hints at a potentially competitive match.
The report also mentions the K factor briefly. That just controls how much the rating changes after each match.
Right, exactly. A higher K factor means ratings can swing more dramatically based on recent results.
Okay, moving on to Poisson regression then. This is the model focused on predicting goal counts.
Right. The idea is that goals in a match happen sort of randomly, but with an average rate, which the Poisson distribution describes.
And the model uses factors like team form, strength maybe from ELO home advantage, odds, injuries.
To estimate that average rate, the expected number of goals, usually called lambda.
Gotcha. So for this match, the Poisson model predicts CF Montreal scoring about 1.72 goals and Philly scoring about 1.41.
So, based purely on that model's expectation, Montreal has a slight edge in expected goals. But again, that's just the average expectation. Any single game can deviate.
And that's where this bootstrap Poisson thing comes in, I guess, to handle the uncertainty.
Yeah, exactly. Bootstrapping here means they run the simulation based on those Poisson rates. Many times the report says 1,000 simulations. And instead of just one number, this gives a range of likely outcomes, a confidence interval.
So what did that show?
For Montreal, the average predicted goals was similar, 1.73, but with a 95% confidence interval of zero point 0 to 4.02 goals.
Wow, so anywhere from 0 to 4 goals is statistically plausible, though the extremes are less likely.
Right. And for Philly, it was 1.39 goals on average, with a range of 0.00 to 4.00.
This just gives a much better sense of the potential variability in the scoreline. It's not just predicting 1.7 to 1.4.
Precisely. It shows the spread. Low scoring, high scoring, both are within the model's possibilities.
The report also quickly summarizes the underlying Poisson models. For the home model, predicting Montreal's goals, it found some interesting links.
Like what?
Like if the betting market thinks there's a high chance of over 2.5 goals overall, market probe over 25, that positively correlates with Montreal scoring more.
Okay, that makes some intuitive sense. High scoring game expectation links to home goals.
But interestingly, if the market thinks both teams are likely to score, market props, that actually showed a negative correlation with Montreal's goals in this specific model run.
That's less obvious. Maybe the model interprets both teams to score scenarios as slightly lower scoring for the home side specifically, compared to games where only they are expected to score heavily. It shows the model is finding specific statistical relationships.
Yeah. And for the away Poisson model, predicting Philly's goals, there were also some correlations mentioned.
Let me guess. ELO rating probably played a part?
Yep, positive correlation. Higher away low linked to more away goals. That seems logical.
Stronger team, more likely to score, even away. Makes sense.
But there were negative correlations too. If the market leans towards an away win, market prob way, or expects over 2.5 goals, market probe over 25, those factors were negatively linked to the number of away goals predicted by this model.
Interesting. Again, it suggests the model is picking up some perhaps counterintuitive relationships, maybe reflecting how odds are set or specific game states. It's not always straightforward.
Definitely not. Okay, so that's the goal prediction side. What about the machine learning models predicting the actual winner?
Right, the classifiers. First up was random forest.
Yeah. Can you break that down simply?
Sure. Think of it like assembling a committee of slightly different experts, in this case, decision trees. Each tree gets a slightly different view of the data and features.
Okay.
They each make a prediction, home win, draw, away win, and the final random forest prediction is just the majority vote from all the trees.
Like wisdom of the crowd, but with algorithms.
Kind of, yeah. It's good because it's robust, less likely to latch onto weird patterns in the data. They mention using SMO-E again and grid search for tuning.
And the prediction for this match.
Random forest predicted a home win for CF Montreal.
Okay, 1 vote for Montreal. The report also mentions precision, recall, F1 scores for it.
Yeah, those are metrics to evaluate how well the model performs for each outcome category. Tells you about its accuracy, basically.
Gotcha. Next ML model. XG boost. Sounds intense.
Yeah, stands for extreme gradient boosting. It's another tree-based method, but it builds the trees sequentially.
Sequentially, how does that work?
Each new tree tries to correct the errors made by the previous ones. It learns step by step, focusing on the mistakes, which often makes it very accurate and efficient.
And its prediction. Also used SMOD in tuning, I see.
Yes, similar training process. And XGBoost also predicted a home win for Montreal.
Okay, that's two strong models pointing the same way.
Yeah.
Random Forest and XGBoost agreeing gives that prediction a bit more weight, doesn't it?
Generally, yes, there are different techniques arriving at the same conclusion.
But then we get the MLP neural network, multi-layer perceptron. That sounds like deep learning territory.
It is. Think of interconnected nodes like simplified brain neurons in layers.
Yeah.
Input layer, hidden layers where the complex learning happens, and an output layer. They can capture really intricate nonlinear patterns.
And they used even more features here, including player-level stuff.
Right. Neural nets can often leverage very detailed data.
But its prediction was different. MLP-NN predicted an away win for Philadelphia Union.
Ah, the outlier. See, this is why using multiple models is valuable. The neural network might be picking up on something the tree-based models missed, or perhaps it's interpreting the data differently.
The report noted its performance metrics, too high precision for draws, but lower recall. What does that mean?
High precision for draws means when it predicts a draw, it's usually correct. But low recall means it misses predicting a lot of the actual draws that happen. So it's confident, but perhaps overly cautious about calling draws.
Interesting nuance.
Hmm.
Okay, last individual model type mentioned is the stacked ensemble.
Right. Stacking or stacked generalization. This is like a meta approach.
How does that work?
You take the predictions from your base models, the random forest, XGBoost, MLP in this case, and use those predictions as input features for a final model, the meta model.
So it learns how to best combine the insights from the other models.
Exactly. It tries to figure out which models are more trustworthy under which conditions, leveraging their collective strengths. Often improves accuracy, but needs careful setup.
And the stacked ensemble's prediction for Montreal, Philly.
It predicted a home win for CF Montreal.
Okay, so that brings it back in line with Random Forest and XGBoost. The meta model seems to have sided with the majority here.
It seems so. And its performance metrics showed high precision for draws, too, interestingly. Suggests it might be quite good at identifying likely ties when the base models provide the right signals.
So we have goal predictions and outcome predictions from different ML angles. What about that Monte Carlo simulation?
Right. The Monte Carlo provides another probabilistic view. They ran 10,000 simulated matches.
Based on what?
Based on the goal rates predicted by the initial Poisson model, the 1.72 for home, 1.41 for away, each simulation randomly generates goals based on those rates.
And after 10,000 simulations, you get a distribution of results.
Exactly. It shows how often each specific scoreline occurred and the overall win-draw loss probabilities.
So what were the key findings from the Monte Carlo?
The single most likely scoreline was actually a 1-1 draw, happening in about 10.55% of the simulations.
Huh. So a draw is the most probable specific outcome.
Yes, but other scores were close behind. 2-1 Montreal, 8.77%, 1 to Philly, 7.52%, 1-0 Montreal, 7.46%.
And the overall result probabilities.
Across all 10,000 simulations, home win for Montreal came out highest at 44.86%. Draw was next at 32.22%, and away win for Philadelphia was the least likely at 22.92%.
Okay, so even though 1-1 was the most frequent score, a Montreal win across various score lines, 1-0-2, 1-2-0, etc., was the most probable overall result.
Precisely. It gives a more nuanced picture than just picking one score. Montreal has the highest overall chance, but a draw is very plausible.
So let's try and synthesize all this then. We've got the Poisson suggesting slightly more goals for Montreal.
Yep.
Random Forest, XGBoost, and the stacked ensemble all predict a Montreal home win.
Right. The majority of the classifiers.
But the MLP neural network predicts a Philadelphia away win. The
Yeah,
outlier.
it's the dissenting voice, yeah.
And the Monte Carlo simulation, while showing 1-1 as the most likely single score, gives the highest overall probability to a Montreal home win, around 45%.
So quite a bit of agreement leaning towards Montreal, but that neural net result and the high probability of a draw in the Monte Carlo keep it from being, a sure thing.
It really underscores the complexity, doesn't it? Different methods, slightly different takes. The models agreeing give stronger signals, but the disagreements are reminders of the uncertainty.
Absolutely. Predicting soccer is hard. There's so much randomness.
Okay, now, this is probably the most important part. Before anyone rushes off thinking they've got a guaranteed winner based on this.
Ah, yes, the disclaimer.
Crucial, absolutely essential. The report clearly states, and we need to echo this, these predictions are strictly for informational and entertainment purposes.
They're based on stats and historical data, but they are not guarantees. They shouldn't be taken as financial advice or betting advice.
Definitely not. Gambling involves risk. It can be addictive, Please be responsible. Only use funds you can afford to lose. If you need help, resources are available.
And this deep dive, it's not an offer or encouragement to gamble. You're responsible for following the laws in your own area regarding betting.
Couldn't agree more. These are fascinating analytical tools, but they can't predict the future perfectly. Unexpected things happen in sports all the time.
Red cards, wonder goals, keeper errors. AI can't foresee all of that.
So, wrapping this up, what's the big takeaway from digging into this Smart Bet AI report?
For me, it's really just the sheer complexity and the variety of techniques involved now. We saw basic stats like ELO, probabilistic models like Poisson, several sophisticated machine learning classifiers, and simulation methods like Monte Carlo.
Yeah, it's a whole toolkit. And it shows how different approaches can sometimes point in different directions, highlighting different potential factors.
Which leads to maybe a thought-provoking question for you listening. Philadelphia has that slightly higher ELO rating, suggesting historically they've been a bit stronger, yet most of these models lean towards a Montreal win here.
So the question is, what underlying factors might the AI be weighing more heavily in this specific matchup?
Exactly. Is it Montreal's current home form? Is it weighing the impact of those specific injuries more heavily against Philly? What do you think the AI is seeing that overrides the slight ELO disadvantage for Montreal?
That's a great question to ponder. And it also makes you think about the live game itself, right?
Yeah.
How might real-time events, things that just aren't in this pre-game data, ultimately swing the match one way or the other, maybe completely defying these models?
Absolutely. It's that inherent unpredictability that makes sports compelling. But understanding how these analytical tools work, how data and probability are used to assess possibilities.
It really changes how we can engage with and understand sports, doesn't it? And maybe think about uncertainty in other areas, too.
Definitely food for thought.